All right, so today we're going to look at solving quadratic inequalities. Before we actually get started on this though, I want to kind of give you an overview of what the concept is what's going on, okay? So bear with me while we kind of go through this. So what we've done so far, right, with quadratics is that we've been solving quadratic equations by graphing them, right? So if I wanted to solve an equation, and I'm just making this up off the top of my head, but let's go with, how about x plus 3 times x minus 5 equals 0, right? So if we wanted to solve this quadratic, we know how we'd solve it. It's already factored, so we just set it equal to 0. We get -3 and +5 as our answers, right? And you can see those points on your graph here, right? This would be -3 and this would be +5. Okay, and we know that those 2 points are a solution because we're looking for what x values give you a y value of 0, right? Here's my y-axis. All right, this is the line where y equals 0. So that's why I'm looking for those 2 points. Okay, so that's what we've been doing while we're solving these as just equals equations. Okay, so now when we start looking at inequalities, what's changing is that now I'm going to have an equation where it's something like this. Okay, so now instead of just looking for the points where my graph is equal to 0 just on this line, I'm looking for what values of x are going to give me something that's greater than 0, right? So now instead of just looking at where y is 0, I'm looking for anywhere that y is greater than 0. So yeah, it's going to be this point, but it's also going to be this point and this point and this point and this point. These are all points where we're greater than 0, right? And same thing over here, these points. These are all points where they're greater than 0. So now my graph, instead of the solution just being this point right here, now my solution is all of these points, which we usually represent by shading to show that we're hitting all of those points. Okay, and that would be my solution. Okay, so great, that's how we'd represent it graphically, but how would we represent this as like an equation? Like here, I would say that x equals -3 and x equals 5. So how do I represent this? Okay, well, representing this in terms of writing an expression, okay, in terms of your x values, so we're talking about the x values. So here's my x-axis. What's going on? Well, these x values are all bigger than 5, right? I don't know exactly what they are, but like here's an x value of 6, it's got a point. Here's an x value of 7, it's got a point, right? So these are all x values that are bigger than or equal to 5. And on this side, these are all x values that are smaller than or equal to -3. So instead of writing just x equals -3, x equals 5, now we're going to have these inequalities. Okay, now that is how this would be represented if we were looking at a 2-dimensional graph. If I wanted to put this on a 1-dimensional graph, right, so just like a standard number line, what would it look like then? Well, now that we know what our values are, now I would just say, okay, well, here's -3, here's 5, right? Those are part of my solutions, so I'm going to put a point there. And it's all of the x values less than -3 and all of the x values greater than 5. Okay, so you can kind of see the connection between these two graphs, right? We're just focusing on what's going on in the x-axis. It's as though instead of squiggling the points on the actual graph, we just squiggled the points on the x-axis that corresponds to those graphs, right? And that's what this is looking like. It's the x-axis. We just took away that second dimension. Okay, so that's the general idea of what's happening here. We're looking at, instead of just finding the point where it crosses the x-axis, we're finding all the points where it crosses the x-axis and where it's above the x-axis because we're looking for greater than 0. Right? Okay, so let's look at some actual examples of what you're going to calculate. Okay, so what we're going to do, we're going to start by finding our x-intercepts, right, plotted on a number line. Then we're going to test to figure out which intervals actually make the inequality true. We're going to graph our solution and we're going to write it as an interval. And we're going to introduce something called interval notation today, okay? So this will be something that's a little bit new to you, but shouldn't be too big of a deal. Okay, so let's take a look. So this guy right here, step 1 is we are going to solve this, okay? So easiest to solve this by factoring 2 factors of -6 that add up to 1. That's going to be x plus 3 times x minus 2. Okay, and I'm just solving this when it equals 0. So notice that I swapped from an inequality to an equal sign. Okay, and then my 2 solutions are going to be x equals -3 and 2. Great. All right, so that's the first thing. Now we're going to make a little number line to graph this. On your number line, I don't particularly care that you fill in all the numbers. I understand that you know how numbers work. So when you're setting up your number line, you don't have to include everything. Just include the 2 key numbers and make sure they're in the right order. So negative on the left of the right, or on the positive number. All right, and now we're going to look at this inequality symbol. So I think you remember this before from previous classes, but if there's no equal to symbol on the bottom, then we put open circles at our 2 key numbers. Okay, so if there's no equal sign, put open circles at your 2 key numbers. All right, if it had an equal to, then we put solid circles. All right, and now we're just going to test a number. So what I'm going to do is I'm going to pick a number in each of these 3 ranges and check to see if it actually makes this inequality true. Okay, so let's take a look. So starting in the middle, right? 0 is in the middle. If possible, 0 is a nice number to use, right? So I'm going to use 0. Plug 0 in. Gone, gone. Is -6 greater than 0? No, that's not true. Okay, so I'm not going to shade this part. We want to shade the parts that make your inequality true. Okay, so what if I test over here? Now, on this side, I could test something like, say, 5, right? And plug this in and do 5 squared plus 5 minus 6 and see what I end up with. But, like, why do something that might possibly work? Okay, if I'm going to pick a number over on this side, I'm going to go, like, crazy extreme. So I'm going to think like the number 10,000. 10,000 is on this side of this inequality. I'm going to test that one. 10,000 squared plus 10,000 minus 6. Yeah, that's definitely going to be bigger than 0. I have no idea what it is, but it's bigger than 0. So I know that this is going to be part of my solution. Similarly, if I looked at over this side, if I do like negative 10,000, right? Because why do something close? Do something extreme that's going to make your life easier. Negative 10,000 squared is going to be a ginormous positive number. So then when I have to add a negative 10,000 squared, is that going to make any difference? No, it's still going to be positive. So this section over here also works. Okay, so that's what my graph is going to look like. And then the last thing that we're going to do is we're going to write this as an interval. So we're writing this in interval notation, which you probably haven't seen before. Okay, but here's how this is going to work. I'm going to express this instead of saying x is less than -3. We're going to use interval notation. All right, so we're going to start with a parenthesis and then an infinity symbol and then a comma, then -3, and another parenthesis in this case. Okay, what's going on? So what this is, these are the 2 boundaries. Okay, we're saying that -3 is one of our boundaries. And on the other side, we're going all the way to, that should be -infinity. So we're going all the way to -infinity on this side, and we're going to -3 here. Okay, now parentheses, we're going to talk about how sometimes you have to use brackets and sometimes you use parentheses. So you use a parenthesis when the number is not included as part of your solution. So because this is strictly greater than, there's no equal to symbol, right? This is not included as part of my solution. That's why I'm going to use a parenthesis. Okay, you also always use parentheses for infinities. That's just a thing. Okay, so on this side, 2 is not part of my solution, so I'm starting with a parenthesis and then the 2. And I'm going from 2 all the way to positive infinity. And there we go. That's interval notation. Okay, so it kind of looks like you're writing points for these ones. It won't always. Okay, cool. Let's move on to this next one. All right, so this guy we're going to factor. And just to save myself some room, I'm going to do this out kind of on some scrap paper. So factoring this guy, 2 times -3 is -6. So 2 factors of -6 that add up would be -6x plus 1x minus 3. So I'm factoring out the 2x. That's going to leave me with x minus 3. Factor out the 1. That leaves me with x minus 3. So it's 2x plus 1 times x minus 3. Okay. So we factor that. Okay, and I'm solving this as though it was equal to 0. So when this is equal to 0, I know that I'm going to get x equals -1/2 and positive 3. If you need to do the workout for that, go ahead. All right, so now let's set up our number line. And again, just include the 2 numbers that you have. Don't worry about filling in the rest of it. Now this guy, looking at this inequality symbol, there's an equal to symbol on the bottom. So we're going to do filled in circles at both of these points. Okay, and now I just have to test my intervals. I'm looking for something that will make this true. So I'm going to start with 0 because 0 is in the middle of these two numbers. Can't always use 0, but if you can, it's helpful. Okay, if I plug 0 in here, this nonsense all goes away. Is -3 less than or equal to 0? Yep. So I'm going to shade this middle section. Okay, if I try, again, my extreme numbers, positive 10,000 is way out here somewhere, right? So 10,000 squared times 2, right, minus whatever else, this part really doesn't even matter. Is that going to be less than 0? No. Okay, negative 10,000 squared is going to be a really, 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 really big positive number. Then I'm going to double it. Doesn't matter if I subtract a few thousand from there, right? It's still not going to be less than 0. So that's going to be my solution. All right, so interval notation, what's this going to look like? So this one, because the -1/2 is included as part of my solution, we're going to use a square bracket instead of a parenthesis. So there's my -1/2, comma, 3. And again, included as my solution, so a bracket, not a parenthesis. Okay? So hopefully you're kind of seeing this interval notation and how this works. I think as you see more of it, it becomes a little bit more clear. All right, this next guy over here. So this one we're going to solve. All right, but in order to do this, we have kind of an issue here with this negative, okay? Because we only ever factor with a positive number in front. So the first thing that I'm going to do is I'm going to multiply this whole equation by -1 so that it'll end up 2x squared plus x minus 6, right? And then I won't have that negative there. Okay, but remember there's that rule for inequalities. You have to flip your symbol if you multiply or divide by a negative. Okay, so now instead of being less than, now it's going to be greater than 0. Okay, and if you kind of think about it, if we'd taken the other approach of moving everything to the other side, right? I could have taken all this stuff and like added this to both sides, added that to both sides, subtracted that from both sides, right? You can kind of see how, oh, well, now all of this stuff would be over here and it would be, you know, Pac-Man would be eating the 2x side, right? Just like it is now. So that should hopefully kind of make sense. All right, let's factor this guy. So 2 times -6 is -12. So 2 factors in -12, that's going to be 4x and -3x. GCF both sides, that's going to leave me with x plus 2. And that'll leave me with x plus 2. So it's 2x minus 3 times x plus 2. Okay, I'm just factoring by grouping. Again, it doesn't matter if you factor by grouping or another method. It's up to you. I prefer grouping because I think it's fastest. And I hate guessing and checking. All right, so my two solutions here are going to be 3/2 and -2. Oop, right, and this was supposed to be an equal sign. My bad. Okay, so here's my number line. -2 would be over here. 3/2 would be over here. All right, testing some numbers. So 0 in the middle of these. If I plug 0 in here, goes away. I'm going to have 6 is less than 0. That's not true. Okay, if I plug in 10,000, 10,000 squared times a -2 is going to be negative, a really, really big number. Definitely less than 0. So I know I need to shade this side. There's no equal to symbol, so it's an open circle. And I'm shading that way. All right, over here, similarly, -10,000 squared times -2 is going to be a really negative large number, right? So that's also going to work. And again, open circle, because that's not part of my solution. Cool, okay, this guy right here. So we are going to start by getting this all on the same side. So it'll be 3x squared minus 27x is less than or equal to 0. All right, this is a GCF factoring. I can factor it out as 3x times x minus 9, switching that to equal 0. And my two solutions are 0 or 9. All right, so the unfortunate thing about that is that now I can't use 0 as one of my test numbers, which is sad. But I could use, say, 1. 1 should be pretty easy, right? If I plug 1 back into this original inequality, I'm going to get 3 is less than or equal to 27. That is true. So I'm going to shade my middle section. I have the equal sign, so I'm putting a point filled in at each of my solutions. All right, and if I tried a really, 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 really big number, right, is 10,000 squared times 3, that's definitely going to be bigger than 27 times 10,000, right? So that's not going to work. And then similarly with the negative 10,000, this will end up positive, that'll end up negative, so that definitely won't work either. Okay, and then our interval notation, square bracket, because it's included as part of the solution, and then 9, included as part of the solution. Oh, and I forgot that over here. Sorry, let's go back to this one really quick. All right, so this guy, I'm going from negative infinity to negative 2, not included as part of my solution. And this side, 3/2 to positive infinity. And the infinities always get parentheses. All right, this guy right here. Brown this time. So I can GCF factor this again. So 3 comes out, and I'm left with x squared minus 16. And then that's the difference of two squares. So 3 times x minus 4, x plus 4. So my two solutions are going to be 4 and negative 4. All right, so number line. Here's negative 4, here's positive 4. I want filled in circles because I have the equal to. Okay, and then when I test some numbers, zeros between there, if I plug 0 in here, right, is 0 going to be greater than, well, this will go away. Is negative 48 greater than 0? No. 10,000 squared times 3, yeah, that's going to be bigger than 0. Negative 10,000 squared times 3, yep, that'll work. Okay, so then for my interval notation, negative infinity always gets a parenthesis. We're going up to negative 4, which gets a bracket because it's included. And on this side, we're going from 4 to positive infinity, which always gets a parenthesis. Excellent. This guy right here, hopefully you can look at that and recognize, oh, hey, that is a perfect square, right? 2 factors of 9 that add up to 6 are 3 and 3. So this is just x plus 3 squared. Okay, so my only solution here is going to be negative 3. Okay, well, that's kind of weird. So let's take a look at this. So negative 3 is my answer. I know it's going to be included as part of the solution because I've got the equal sign. Okay, and let's test some numbers. So positive 10,000, 10,000 squared plus some more thousands. Yeah, that's going to be greater than or equal to 0. So that works. Negative 10,000, negative 10,000 squared plus some other stuff. Yep, still bigger than 0. So that works too. Okay, well, what does that mean? So we just shaded literally everything on our number line. Well, what that means is that this is all real numbers. Okay, so anything will work for this guy. Okay, in terms of what's happening here graphically, we looked at graphically what happens. What this is telling me is it's telling me that my parabola is somewhere up here, right? And then you're asking, well, where is this greater than or equal to 0? Always, right? It's totally, completely, always above the x-axis. So it's always going to be a solution. Okay? All right, let's look at the next one. You're going to notice this is the same problem. It's just a slightly different inequality symbol. So I know my solutions are going to be at negative 3. And let's take a look at my number line. So here's negative 3. It's not a solution because there's no equal to. If I plug in 10,000, well, 10,000 plus 3 squared, yeah, that's bigger than 0. Negative 10,000 plus 3 squared, yep, that's bigger than 0 too. So what we've done now is we've shaded everything on our number line except for negative 3. Okay, so negative 3 is the only number that doesn't work. Everything else works. Okay, so you could try to write this in interval notation, but it would feel kind of stupid, right? So what you usually write for these is you're just going to say x cannot equal negative 3. Okay, because it just makes more sense in this case to say we've got one excluded number rather than saying all the ones that are included. All right, this guy right here, similar. We still know that x equals negative 3 is our answer. Let's take a look at our number line. So not included as an answer, so open circle. If I plug in 10,000 here, 10,000 squared, is that going to be smaller than 0? No. Negative 10,000 plus 3 squared, is that going to be smaller than 0? Also no. So what's happening? Well, when I look at this, nothing works, right? We said this doesn't work, that doesn't work, that doesn't work. So this one, there's no solution. Okay, so there's no solutions to this. And what's happening to this graphically? Well, if we were to look at the graph of what this looks like, what this is telling me is that my graph is going to be somewhere over here, right? And we want to know, where is this graph less than 0? Well, it's never less than 0. It's always above the x-axis or on the x-axis. So it's never less than 0, so there's no solutions to this one. All right, and then this last guy here. Okay, so again, x equals -3. Right, if we take a look at our number line, here's -3. That's included as part of the solution, so that's good. 10,000 plus 3 squared, not smaller than 0. -10,000 plus 3 squared, also not smaller than 0. So the only thing that works for this guy is -3. So similar to this problem, instead of saying everything like, well, actually, no, I guess we are just saying everything that does work, right? Everything that works is x equals -3, and that's it. Okay? All right, so that is the general idea, and those are kind of your special cases that you want to watch out for. Okay, so that's when you're going to get strange things that happen. All right, now these next few, so those were all ones that factored pretty easily. Okay, so these next couple that I want to look at, we're going to take a look at these and figure out, okay, well, what's going on with these guys? They don't factor. So what you're going to do instead is use a quadratic formula. Okay, so we'll use a quadratic formula and we're going to solve this, and it'll be fairly straightforward, okay? We're not going to do all 4 of these because it's just kind of not worth of our time, okay? So let's take a look at what's going to happen. So again, I'm going to do some side work for this guy. So opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So -1 plus or minus, this is going to be 1. This is going to be plus 64 over 4. Okay, so I've got -1 plus or minus the square root of 65 over 4. All right, great. So those are our 2 solutions. All right, so we've got x equals -1 plus or minus root 65 over 4. And I have faith in your ability to figure that part out. So what's going on with my number line? Yuck, right? Okay, so this is where -1 minus the square root of 65 would be. This is where -1 plus the square root of 65 would be, right? And I just know that because if I'm subtracting, it should be smaller, and if I'm adding, it should be bigger. Okay, but then the question becomes, well, what else is happening around here? Where is 0? Is 0 necessarily between the 2 of these? No, not necessarily. It could be, but it's not necessarily between them. Okay, so you got to kind of like stop and think about this. Okay, because like say we had a problem where it was 10 plus or minus the square root of 4 over 2, right? Well, when we broke this, because we know the square root of 4, that would be 10 plus 2 over 2 and 10 minus 2 over 2. Is 0 between those 2 numbers? No. So we're not always guaranteed that 0 will be between these solutions. You're going to have to kind of think about that and figure out where it is. Okay. I do know positive 10,000 is definitely way over here. So positive 10,000, when I plug that in, is that going to be bigger than 0? Yeah. So I know, open circle, I can shade this way. Right? Negative 10,000 squared times 2, definitely bigger than 0. So I can definitely shade this way. But we do have to test because it could be an all real number problem. So you do have to kind of figure out what numbers in between these 2. And it just so happens with this one that 0 will be. Square root of 65 is like 8-ish, right? So -1 minus 8 and -1 plus 8, those are going to end up on opposite sides of 0. So 0 would work here. If I plug that in, I'm going to get -8 is greater than 0. That's not true. So that's it. Okay, so our interval notation would be from -infinity to 1 minus root 65 over 4. And then from -1 plus root 65 over 4 to positive infinity. All right, great. All right, so that's kind of the general idea of what you're going to do with these. I'm going to skip this one just because this video is getting kind of long, and it's the same sort of problem. But I do want to look at these 2 down here. Okay, so for these two, I'm not going to go through the steps of solving these with the quadratic formula because, again, I know that you can do that. So just trust me that when I say, when you solve this, you're going to get -1 plus or minus I root 39 over 4. Okay, so that's what's going to happen. Lovely. Okay, well, how's that helping me? Okay, well, I've got an imaginary number here. So what happens with an imaginary number? Well, imaginary numbers we know tell us that our graph doesn't cross the x-axis. Okay, so let's think about what this graph is going to look like, right? And actually, I'm going to go ahead and draw it here. So we think about this graph. It doesn't cross the x-axis because I've got this I. I know the y-intercept is +5, and I know that it opens up, right? So this graph is going to look something like this. All right, and I can just tell that based on the equation and what we know about a values and y-intercepts. So I'm looking for where is it going to be greater than 0? Well, where's this one greater than 0? Always. So this one is going to be all real numbers. Okay, so I can just look at my graph and I can kind of figure that out from there. Similarly, when I look at this guy over here, right? Again, just take my word for it that when you solve this, you're going to get 1 plus or minus I root 47 over 6. So again, imaginary solution. All right, and when I look at this guy, I can sort of figure out what my graph is going to look like. I know that it opens up, so it's a U shape, and it has a y-intercept of 4. So it's going to be something similar looking to the last guy. Something like that. Doesn't cross the x-axis because I have imaginary solutions. And then this is asking me, where is this graph less than or equal to 0? Here's 0, here's less than 0. So when does that happen? Never. So there is no solution to this problem. Okay, so when you get an imaginary answer, that doesn't tell you anything, okay? All it tells you is that you're not going to cross the x-axis, right? And you'll know that you'll have either all real numbers or no solution. Okay, but you have to do the testing to figure out which case you actually have. All right, so just make sure that you stop and think about these because you can have ones where they end very similarly, but you get different sorts of answers. Just like here, right? This was the same problem 4 times, but we got 4 different answers. Okay, so you really have to be careful and just pay attention and make sure that you know what you're doing and you're doing it correctly. Okay, so that is kind of your summary. Make sure that you're okay with your different symbols and that you know which one's which. Okay, so specifically know that when you have just a less than or just a greater than, then you're going to do an open circle, right? And when you do your notation, you're going to use parentheses, right? And if you have less than or greater to or less than or equal to or greater than or equal to, you know what I'm trying to say, right? Then you're going to have a closed filled in circle and you're going to use your square brackets. Okay. All right. And that is solving inequalities that are quadratic.